very delighted to be here together with Daniel today to be able to deliver to you some interesting information about generative AI, about its potential benefits, but also its potential pitfalls with regards to the applications in our industry, in the publication industry, and also some policies that have started being created on how generative artificial intelligence should be used responsibly in the context of scientific writing and in the publishing process. So without further ado, we will proceed with the main content of the presentation. This is split in three parts. In the first part, we're going to talk about the generative artificial intelligence, how we have arrived a bit here, and its importance currently in many text-to-text applications. The second part is about its importance in the publishing community, and Daniel will lead the third part with regards to artificial intelligence in Elsevier. So let's get started a bit with a bit of a discussion, if you may, around generative AI. So as we have seen in the last 18 months, the whole world has been taken by storm with the evolutions in the field of artificial intelligence. We've seen bots like ChatGPT and other vendors of AI releasing engines that are very impressive in what they can do. They can answer questions, they can chat in a fashion that looks like intelligent fashion. And in practice, this has, for many, been a period where very many such technologies have come out very fast, and there is an explosion of those. But in reality, this has been the outcome of more than 70 years of research in the field of artificial intelligence. Indicatively, in the 50s, we had the perceptron. Later in the 70s and the 80s, we started looking at multi-layer perceptrons, escalating in the 90s with backpropagation, introduced by Jeff Hinton. And then already in the 90s, we had RNNs and CNNs, and then later LSTMs in the 2000s that have been, all of them, the basis of the evolutions we see today. So the basis of deep neural networks and deep machine learning has been there already for some decades. It's just recently, of course, there has been exciting things in hardware and in software that has enabled this explosion. Now, when we talk about generative AI, what we mean, of course, is a very particular field of machine learning, which is also in turn a subfield of artificial intelligence that is brain inspired. And it's all about deep neural networks being able to learn representations or understand how different things relate in terms of features when they are fed with large amounts or large volumes of data. A very exciting category of generative AI models is, of course, a category that is called large language models. These are models that are basically able to understand language in the sense of what tokens or what sequence of words can come next when a particular prompt is actually input to these models. So these models, we call them also text-to-text models, are of course the basis of the excitement in our industry, and they create a lot of opportunities while in parallel they carry a number of risks. We need to be aware that earlier, before the advent and the explosion of generative artificial intelligence, we still had more traditional machine learning and AI approaches, also partly being able to generate. For example, we had abstractive summarization before the advent of deep neural networks. However, it is very obvious that this new technology is able to crack a lot of these natural language processing problems in a much more efficient fashion. In reality, besides text-to-text, which is the experience most of you and most of us have in majority from these models, there are also obviously generative AI models that can take you from text to images. You can generate images given a prompt. You can generate code. You can generate audio. So text-to-text is just one part of it. There are many more modalities. And of course, what is very interesting to note is that also these models, and in particular the large language models, are autoregressive. So they understand context and they work in a way that every time they produce the next word, this new word, together with the previous input, becomes now the new whole input for the next generation of a token. Now, with that input in mind, the way in practice these models are used is, of course, by prompting them to be able to derive an answer or a summary or to ask them to do a particular task. In that fashion, that there have been a number of prompt engineering techniques that have been introduced. For example, techniques that and kind of suggest to the model that it takes a particular role. For example, it becomes a chat assistant for a customer service, or it becomes something else, so role modeling there. But also other types of techniques, trees of thoughts, and other types of prompt engineering techniques that can make the most out of such a large language model. Now, let's proceed a bit further to discuss a bit how this interesting, very important evolution in the field of artificial intelligence affect, if you may, the publishing community, but also what are some risks and what are some opportunities. First of all, when we actually discuss around generative AI in the context of scientific writing and scientific publishing, I believe by now we all have a bit of similar view that this is going to be more and more a larger discussion, and more of the actors in the whole publication process, from authors to editors to reviewers, they are going to be more and more involved and curious on how this new technology can actually help them achieve their goals. And obviously, in the particular aspect of scientific writing, we do expect that more and more researchers will be increasingly interested in understanding how GAI can help them in scientific writing and in the publishing process. Now, this, of course, raises a few very important questions. As much as this technology is exciting, researchers might be wondering how and if are they allowed to use such a technology in the scientific writing process? How can they disclose any information of such usage? Or even further, could they even present such a model as a co-author or co-writer or a collaborator in their research? So these are very important questions. And of course, they are even more important in the context of some of the threats that this technology carries with, including sometimes hallucination and inaccuracy in the produced output, or even producing completely unreliable, if you may, output to a particular prompt. We will talk about some of these threats in a bit more detail in a moment. But these are indeed some of the very valid questions that have appeared in the recent past. Now, let's start going a bit deeper in terms of what are some of these important risks of generative AI in the process of scientific writing. First of all, let's start with the very known properties of these models, which is, of course, they may hallucinate. And let me clarify here, because a lot of times we talk about hallucination also in research papers, in the context of discussing performance of LLMs in the media. But it's not very clear when we talk about hallucination, what do we mean when we talk about hallucination of a large language model? And there are two aspects in the hallucination definition, at least epistemically. The first aspect is the truthfulness of an LLM and the output it produces to the sources that it has seen. That is the first aspect. Hence, we may say a model that is not producing an output that is truthful to the sources, it hallucinates. But there is one more aspect when we talk about hallucination that is very important, and it's the factuality of the generated output given a particular prompt. And these two together comprise normally what we mean in the AI community as hallucination parameters, factors. So in that regard, currently LLMs we do observe that they have this notion that because they are, of course, providing a probabilistic output, at the end of the day, that's what an LLM is, provides a probabilistic output to every single prompt. They will try to enforce an answer, to push an answer, even if they are not very confident this is actually the right answer, or even if this answer is fabricated or generated. Hence, we have the phenomenon of hallucination, and this, of course, carry many risks, because it could be fabricated references or completely fabricated conclusions or output given a particular prompt. Another issue and risk with the LLMs has to do with the biases and the different nature, if you may, of characteristics of the sources that have been used to pre-train, as we say, such a foundational model. Because every LLM starts as a foundational model, having seen a lot of content to build that language model in its memory, and then it can proceed with some fine-tuning to become more expert and more performant in particular tasks. Now, these sources need to have a very good analysis and investigation with regards to whether they carry some biases or whether they carry some unethical or content, or even some content that should not be even presented to such a model, so that's not picked up. So in other words, depending on the sources, such a model could be, by definition, by its pre-foundational training, foundational training could be biased. And the other aspect, which is a very important risk, is the aspect of how up-to-date these models technically can be. We know for a fact from the very big models that are out there, such as the GPT-4 or the GPT 3.5 Turbo, these are models that cannot be updated frequently. And most of them are frozen in time by means of what type of information they have 2 or 1 year ago. So they only have not the latest, but up to 22, the information that is available out there. So that is also a problem, though, when it comes to scientific writing. And of course, we should not forget that many of these models that are out there publicly available are also trained in a very generic fashion. They are trained for a very particular task in mind, which is conversational interaction and search, but not necessarily for a particular domain, right? So they are not trained necessarily in scientific content. They are not expert models that understand scientific language, that understand scientific style, and the epistemics behind what it means to conduct research for a scientific paper.